Hello everyone, welcome to Apex Mathematics. My name is Bino. In this video, we go through the following question which is based on number series. 3.1, we are given the geometric series which contains 3 as the first term and 6 as the second term and 12 as the third, and this series continues up until n terms. And 3.1.1, we write down the general term of this series. For a geometric pattern, we have Tn is equals to a multiplied by r raised to the power n minus 1, where the a is equals to term number 1 and term number 1 is equals to 3. It was given as 3, and r will be equals to term number 2 divided by term number 1, and term number 2 it was given as equals to 6, and term number 1 is equals to 3. So 6 divided by 3 is equals to 2. So our r is equals to 2. So we substitute. So we have Tn is equals to 3 in the place of the a multiplied by 2 in the place of the r, and this 2 will be raised to the power n minus 1, and this will be our general term for this geometric series. Question 3.1.2, we calculate the value of k such that the sum from p is equal to 1 up until to k of 3 divided by 2 multiplied by 2 raised to the power p is equal to 98,301. We have to realize that the Tn inside the summation is just the same as the general term of the series that we just determined, this one. So let's simplify this Tn. So we have Tn is equals to 3 multiplied by, suppose that we had a raised to the power b minus c is equals to a raised to the power b multiplied by a raised to the power negative c. So in the same way, we'll have 2 raised to the power n multiplied by 2 raised to the power negative 1, and our Tn will be equals to 3 multiplied by 2 raised to the power n, and we take that 2 raised to the power negative 1 from the numerator to the denominator, and the exponent will change sign to positive 1. So we can realize that what we have inside the summation is just the same as our Tn. So we can just use the a is equals to 3 and the r is equals to 2 to determine the value of k, because if we were to expand what we have inside the summation, we will get 3 as the first term and 6 and 12 as the second and third terms respectively. So we have to determine n or k. So the sum of a geometric series, we have Sn is equals to a multiplied by r raised to the power n minus 1 divided by r minus 1, and the Sn was equals to 98,301. So we have Sn is equals to 98,301. We are to determine n, and it should be obvious that n will be equals to the k that we are looking for. In the place of the Sn, we go right ahead and substitute the 98,301, and this will be equals to a, and in the place of the a we have 3. So our a is equals to 3, the first term, and our r is equals to 2, and we have to determine the n, and this will be divided by 2 minus 1. So we have 98,301, which will be equals to 3 multiplied by 2 raised to the power n minus 1. The 2 minus 1 in the denominator will be 1. We divide both sides of the equation by 3. And 3 divided by 3 will be equals to 1. So the 3's will cancel out, and we have 98,301 divided by 3, which is equals to 32,767. And this will be equals to 2 raised to the power n minus 1. We move the 1 from the right to the left, and it will change sign to positive 1, and this will be equals to 2 raised to the power n. 32,767 plus 1 will be equals to 32,768, and this will be equals to the 2 raised to the power n. So the 2 raised to the power n will be equals to 32,768. Since on the left hand side we have 2 raised to the power n, even on the right hand side we must have base 2. So why should we have base 2? Because the examiner knows that logarithmic laws are not part of your syllabus. So through trial and error, we must find an exponent which will base the 2 so that it will be equals to 32,768. So we start with 2 raised to the power 10. And 2 raised to the power 10 is equals to 1024. So let's try 2 raised to the power 11. This is equals to 2048. So we try 2 raised to the power 12. And is equals to 4096. So let's try 2 raised to the power 13. 2 raised to the power 13 is equals to 8192. So we try 2 raised to the power 14, which will be equals to 16,384. So we try 2 raised to the power 15. 2 raised to the power 15 is indeed equals to 32,768. So our exponent through trial and error is 15. Since the bases are the same, in order for this equation to balance, our n will be equals to 15. Question 3.2 reads, a geometric sequence and an arithmetic sequence have the same first term. The common ratio of the geometric sequence is 1 over 3. The common difference of the arithmetic sequence is 3. The sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence, and we calculate the value of the first term. So this question combined geometric sequence with an arithmetic sequence. In both cases, the first term is the same, so A, the term 1, we denote it by the letter X. Since the geometric and the arithmetic sequence have the same first term, we also denote the first term A, or the term 1 of the arithmetic sequence, with the letter X. We are also told that the common ratio of the geometric sequence R is equals to 1 divided by 3. For the arithmetic sequence, we are told that the common difference D is equals to 3. And we are told that the sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence. The instruction doesn't say that they are equal. We are told that the sum of the 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence. So how can we make the sum to infinity to be equals to the sum to 22 terms of the arithmetic sequence? How can we make them to be equal? So it's supposed to be 22, not n. So how can we make the sum to infinity to be equals to the sum to 22 terms? If I have 3 apples and you have 5 apples, in order for us to have equal number of apples, is either 2 apples are taken from you or 2 apples are given to me. Since we are told that the sum of 22 terms of the arithmetic sequence is 734 more, is either we minus 734 from sum to 22 terms, or we add 734 to sum to infinity for the equation to be balanced. So let's add 734 to the sum to infinity for our equation to be balanced. Since our equation is balanced, we go and determine the sum to infinity and the sum to 22 terms separately, and then we'll substitute them into this equation. The sum to infinity is defined as A divided by 1 minus R, where the A, or the first term, we denoted it with the letter X, and this is divided by 1 minus R, and our R is equals to 1 divided by 3. Let's now determine the sum to 22 terms of the arithmetic sequence. So we have the sum to n terms is equals to n divided by 2 into 2 multiplied by A plus n minus 1, all of which is multiplied by D. Sum to 22 terms, in the place of the n we have 22, will be equals to 22 in the place of the n divided by 2 into 2 multiplied by A, but we said that the first term for now is X plus 22 minus 1 multiplied by 3. Our common difference was given as 3. Sum to 22 terms will be equals to 22 divided by 2 is equals to 11 into 2 multiplied by X plus 22 minus 1 multiplied by 3 will be equals to 63. So we are going to substitute this into that equation. So we have 734 plus the sum to infinity, which we determined as x divided by 1 minus 3. 1 minus 3 is equals to 2 divided by 3, and this will be equals to the sum to 22 terms, which we just determined as 11 into 2x plus 63. On the right hand side, we distribute the 11 inside the parentheses, and 11 multiplied by 2x will be equals to 22x plus 11 multiplied by 63 is equals to 693. And from here, for that fraction, for this particular fraction, suppose that we had a divided by b divided by c. This will be equals to a multiplied by c divided by b. We replace this with 3 multiplied by x divided by 2. From here, let's group the like terms. So we have 734. We move the 693 to the left, and it will change sign to negative 693, and this will be equals to 22x, and we move the 3x divided by 2 to the right. It will change sign to negative 3x divided by 2. 734 minus 693 is equals to 41. And 22 minus 3 over 2 is equals to 41 divided by 2, which in fraction form is equals to 20,5, which we multiply with the x. From here, we divide both sides of the equation by 20,5. And 20,5 divided by 20,5 will be equals to 1. So they will cancel out each other. Finally, 41 divided by 20,5 is equals to 2. So the x, or the first term, is equals to 2. So x is equals to 2. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content beneficial.